Hello, I'm Michael Bienvenu. I am an instructor for Encobridge. I teach paving level 1, paving level 2, asphalt plant level 1, asphalt plant level 2, asphalt mix design, quality control manager, concrete field inspection, earthwork level 1 and earthwork level 2. Today we're going to cover the proficiencies for earthwork level 1 that you would have to take in order to earn your certificate to work on DOT projects. So the two hands-on proficiency tests for earthwork level 1 are the nuclear gauge density of the soils and also the moisture content of the soils using the speedy moisture gauge. We use these two numbers to determine the dry density of our particular lift. The first thing we're going to do is we're going to look at taking a nuclear density reading with our nuclear gauge to determine if the contractor is actually achieving the density in the field that contractor is supposed to be achieving. So the first thing we need to do, we have this nuclear gauge. There are several manufacturers of nuclear gauges, and whichever one is approved by the department, you're welcome to use. But before we can use it, we have to do a couple of things. One, we're going to need to turn it on and let it warm up, okay? Once it's warm, we need to do what we call a standard block test verification. And what we're doing here, we want to see if the gauge is drifting in any way, if it's still good, or do we need to have it recalibrated before we can use it. So the first thing we're going to do is we're going to put our gauge on our standard block. Notice the handle is in the front with this, they call it a scaler, but it's a keypad. And right up in here, we see that it's up against a metal piece. Okay, it's up again. That's when it's properly set. So once we do that, we'll press standard, and it's going to take a standard count, and it's going to give us a standard density count and a standard moisture count. We will compare it to the average of the previous 4 days. If they are within the tolerance range, we can now use the gauge to start taking our density test. Once we've taken our standard counts, the best practice is to remove our gauge from our standard block and to return it to our carrier, the box that we put it in for safety purposes. We're going to take our first density test in the field, and the way we take a density test on earthwork, let's say we have a 6-inch lift that the contractor's compacted. What we need to do is we need to put this drill rod where a random number falls and drive this drill rod 2 inches at least below the measurement depth. For instance, if we have a 6-inch lift of material, we want to be able to be sure that we're going to go down to 8 inches with our drill rod. Okay. Now, one thing I didn't tell you is we need to use this extruder for my drill rod, because you will only do it one time where you forget it. Once you drop this down 8 inches, it's going to be difficult to remove it without this extraction device. Twist it and we'll take it out. So we need to be sure that we're doing all of that information. Once we're done, we want to mark our template, right? Which is the outline of my template is where my gauge is going to be, and I put that outline there because the bottom of my gauge matches the dimensions of this particular template. So once I've got this drawn, I'm going to remove my template, okay, and I have my hole right here, that 8-inch hole that I drilled, and I'm going to move the gauge inside of that template that I drew on the soil, so that my source rod, this is a source rod, this is an index rod. This is going to tell me how deep I'm going. It's a 6-inch lift, so on here there are indexes, 2 inches, 4 inches, 6 inches. I'm going to drop my source down 6 inches into my hole that I made with my drill rod. I can't do it here, but we'll go ahead and drop it down, okay? And the next thing we're going to do is, once we have it in the hole, we're going to slightly pull it back so that my nuclear source is in contact with the wall of my drill rod hole. That way, when my nuclear source is transmitting radioactive material, it's going to be picked up by my gauges without any air gaps or anything. Air gaps will reduce my density, so I want to be sure that I'm not measuring air gaps. Then I'll press start, okay? And after I press start, it's going to measure for a certain amount of time. DOT probably wants you to do it for 1 minute. Okay, so you're going to do 1 minute. We have all this. And when it's done, you're going to scroll up and down and record all of the information that this gauge is going to give you. It's going to give you a wet density. It's going to give you a moisture content, which we may or may not be able to use. It's going to give you a density count and a moisture count, which are from the nuclear tubes that are reading this information. It will give me, in some cases, the dry density, and it'll also give me the moisture count. It'll give me the dry density of my sample in the field, and then I can compare that dry density to the proctor that I'm getting from the lab. We don't cover the proctor in this class because that's a laboratory test, and this is not about laboratory testing. So once we get this dry density from this current test, we'll be able to compare it to the proctor from the lab, and that will tell us, has the contractor actually achieved the target density for that project, so that my pavement won't sag or slump or anything like that. We want it to be strong. We use density of the soil to relate to strength. Okay, we don't actually measure strength. We use the density from the strength. This gives us the strength that we need.